Alright, let's keep going with this. So we're going to go x plus y. And you can put numbers in here. That y could have been that 3 that we were working with, right? So x plus y to the what? To the 5th. So let's do that. Let's look at the 5th row. Here's our row right here. So it's 1, 5, 10, 10, 5, 1. So it's going to be what? 1 x to the 5th plus 5 x to the 4th y plus 10. Look at what my x's keep doing. They keep going smaller and smaller, don't they? And my y's start at 1 and they keep getting bigger. Plus what? Another 10, right? And that's going to be x what? Squared and y cubed. See that? The x's keep going down, the y's keep going up. Plus 5, and then that's going to be an x, and that's going to be y to the 4th, and plus what? 1, y to the what? 5th. Look, the x goes x to the 5th, to the 4th, to the 3rd, 2nd, 1st, nothing. Then the y starts off nothing, right? Then it goes to the 1st, 2nd, 3rd, 4th, 5th. Coefficients, 1, 5, 10, 10, 5, 1. Just like those numbers are right there.
You can check yourself.
Yeah, just count down, you mean? Yeah. That's what you want to do. 5, 4, 3, 2, 1, right? And then 1, 2, 3, 4, 5. Exactly, okay? All right, does that make sense? All right, let's actually do a problem with this. They call this, by the way, they call this whole thing binomial. Binomial, if I can spell. Binomial expansion. Right? That's what this whole process is called. It's binomial expansion. Because look, you've got a binomial in here, right? X plus y. You're taking it to certain powers. So that's why they call it binomial expansion. You see we expanded it, we made it bigger, you know, multiplied it all the way out. You could have sat here and done this. You could have gone x plus y times x plus y. You get it? You could have done this if you wanted to. You'd still get the same answer. But look, just writing the thing out before I even worked was almost as much work as it took to write this out, knowing the patterns. But then what would you have to do? Multiply these two together, get an answer, right? Multiply these two together. Well, actually, once you get this, you know that's going to be the same thing, but you still have to multiply those two big things together, right? And then once you get that answer, then you got to multiply it by this at the end. That's a lot of extra work, isn't it? Now, could you do that? Yeah, you could, but I don't want to. This is a lot better way to do it. All right, let's do a problem, and we'll erase all this, and we'll use this process. Actually, you know what I'm going to do? Just so I don't have to write this over again, I'm going to copy this. Okay, and then, all right, we cleared the slate here. Let's do, tell you what, let's do that one that we were working on. That x, what was it, x plus 3? And let's take it to the 5th. All right, because that's what we said we were going to do, right? So let's take it to the 5th and see what we get. Let's write out the, oh my gosh, I am not keeping track of time. I'll tell you what, you kind of get the idea. Yeah, I don't have time. I think you can still do this. All right, so I think what we covered was good. Now watch, instead of a y, what's going to go in place of the y? Right, now if the 3 is being squared, what do? You square it and you get a 9. If it's being cubed, what do? You cube it. It's 27. You follow me? So simplify the things. Alright, so if you can multiply them, make sure you multiply them and simplify them. But really, this works out just the same way that we did when we said x plus y to the 5th, but it's just a number. Alright, so let me give you a worksheet. I think you only have to do like the first 4 or 5 of those.